the universe of the very small. The foregoing discussion has likely impressed on you that the universe is extraordinarily large and extraordinarily empty. On average, it is 10,000 times more empty than our galaxy. Yet, as we have seen, even the galaxy is mostly empty space. The air we breathe has about 10 to the 19th power atoms in each cubic centimeter, and we usually think of air as empty space. In the interstellar gas of the galaxy, there is about one atom in every cubic centimeter. Intergalactic space is filled so sparsely that to find one atom, on average, we must search through a cubic meter of space. Most of the universe is fantastically empty. Places that are dense, such as the human body, are tremendously rare. Even our most familiar solids are mostly space. If we could take apart such a solid, piece by piece, we would eventually reach the tiny molecules from which it's formed. Molecules are the smallest particles into which any matter can be divided while still retaining its chemical properties. A molecule of water, H2O, for example, consists of two hydrogen atoms and one oxygen atom bonded together. Molecules, in turn, are built of atoms, which are the smallest particles of an element that can still be identified as that element. For example, an atom of gold is the smallest possible piece of gold. Nearly 100 different kinds of atoms, elements, exist in nature. Most of them are rare, and only a handful account for more than 99% of everything with which we come into contact. The most abundant elements in the cosmos today are listed here. Think of this list as the greatest hits of the universe when it comes to elements. All atoms consist of a central, positively charged nucleus surrounded by negatively charged electrons. The bulk of the matter in each atom is found in the nucleus, which consists of positive protons and electrically neutral neutrons, all bound tightly together in a very small space. Each element is defined by the number of protons in its atoms. Thus, any atom with 6 protons in its nucleus is called carbon. Any with 50 protons is called tin, and any with 70 protons is called ytterbium. The distance from an atomic nucleus to its electrons is typically 100,000 times the size of the nucleus itself. This is why we say that even solid matter is mostly space. The typical atom is far emptier than the solar system out to Neptune. The distance from Earth to the Sun, for example, is only 100 times the size of the Sun. This is one reason atoms are not like miniature solar systems. Remarkably, physicists have discovered that everything that happens in the universe, from the smallest atomic nucleus to the largest superclusters of galaxies, can be explained through the action of only 4 forces: gravity, electromagnetism, which combines the actions of electricity and magnetism, and 2 forces that act at the nuclear level. The fact that there are 4 forces, and not a million, or just one, has puzzled physicists and astronomers for many years, and has led to a quest for a unified picture of nature.